Hello, welcome. In this video, we'll talk about how we find the side of a right triangle that's formed by a radius of a circle and its tangent line. So just some quick background information. Let's call this circle, we name circles by its center point usually. So let's call this circle A. And this point right here, we'll go ahead and call it B. And this point, we'll just go ahead and stick with the pattern and call this C. So this segment BC is tangent to this circle A at the point B. And when that happens, that means AB is the radius. This is the radius of the circle. And that means that a tangent line and the radius, they are at right angles to each other. So this is a right angle. And and not only that, but if we go over here and call this point D, but we could say segment CD and segment CB. If you have two lines that are tangent from the same point to the same circle, those two segments will be congruent, which means that if this is 7, then this is 7, and if this is 17, then this is 17, and if this is 342, then this is 342. So their measures will be the same. But then if I go ahead and extend a segment out from A, not very nice looking there. Let's try that again. A segment from A to C, then we have a right triangle, and we can kind of see for that point, we can say I'm calling this angle B, then this would be little b over here, and that'd be our hypotenuse, and opposite C over here, our radius would be little c, and opposite big A over here would be little a. And so then in this particular instance, the square of the one leg, C squared, plus the square of the other leg, A squared, would be equal to the square of the hypotenuse, which in this case would be B squared. We're usually used to seeing C over here in the hypotenuse, but that's what would apply in this case. So this is what we're going to do over here. We know that here is the radius. This is the radius right here. The radius is 3. And this is the tangent line, the one that's marked with 4. And that's segment BC or CB, either way. Then 4, we know that the radius and the tangent line are at right angles to each other. And so that means that this is our hypotenuse. And so we want to know the length of segment AC. We'll go ahead and call that X. So this is our X. And so the square, so what we've got then is we've got 3 squared plus 4 squared equals X squared. And 3 squared is 9, and 4 squared is 16. X squared is still X squared. 9 plus 16 is 25. And if that's equal to X squared, the opposite of squaring is taking the square root. So X then is equal to the square root of 25, which is 5. And that's how we do it. Thanks for watching.